This video lesson is the Pythagorean theorem. Make sure you take good notes on this. The sum of the squares of the lengths of the legs of a right triangle is equal to the square of the lengths of the hypotenuse. And that is the Pythagorean theorem. So we've got words here, the right triangle, got to make sure we understand that terminology, legs and hypotenuse. So if we draw a picture of a right triangle, and you can see in green I've got leg 1 and leg 2, and then there's the hypotenuse. Now the hypotenuse is always opposite the right angle, and it's always the longest side of a right triangle. It's also easy to remember if you just use your hand and you extend your thumb and your index finger so that it forms a right angle, and you'll see the letter L. Well, those two sides would be the legs that makes the L. Those are the two sides that make the legs of the right triangle. So you get your right triangle and the legs make that L shape. And the Pythagorean theorem says you square the leg, the first leg, and you square the second leg, add those two together, and it'll equal the square of the hypotenuse. It's hard to use the words legs, so let's just give them some letters, and we use any arbitrary letters. We happen to use often the letters A, B, and C. We could use any letters we want, but we're going to use A, B, and C. And so instead of the words leg and hypotenuse, we plug in for the first leg it's A, for the second leg it's B, and for the hypotenuse we have C. And so typically we hear the Pythagorean theorem stated as A squared plus B squared equals C squared. But truly it's the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. Let's look at some examples. So we're going to solve for x, and we're going to be using the Pythagorean theorem. So in this first problem, we have this triangle. You should draw this or write the numbers down. Try to solve it yourself. Pause the video, and then in a few seconds we'll have the answer. So using the Pythagorean theorem, we've got the square of the legs, so 6 squared plus 18 squared equals x squared. Now we want to solve for x, so we would just take the square root of both sides to solve for x. And now we just need to simplify the radicand, the part that is underneath the radical symbol. And so we've got the square root of 36 plus 324. Adding those together, we get the square root of 360. Simplifying the square root. Do not put that in your calculator to just get a decimal answer. You need to actually simplify this. So the square root of 360 is 36 times 10, which is a square root of 36 times the square root of 10. We're factoring out that perfect square so that we can take the square root of 36, which is 6, and so the answer is x equals 6 square root of 10. In our second problem, we have this triangle with a leg of x minus 2, a leg of 4, and the hypotenuse of x. And we're going to solve for x. So pause the video, work it out, and then when you're done, I'm going to start up again. So we have the square of the legs equals the hypotenuse squared. We add the legs, the sum of the squares of the legs. And now you're going to have to multiply that x minus 2 quantity squared, which remember that is x minus 2 times x minus 2. And if you remember from Algebra 1, a lot of times people use the terminology of FOIL. You're going to FOIL those out first. You're going to x times x is x squared. Then you've got x times negative 2, so negative 2x. Then you have negative 2 times x, which is negative 2x. And negative 2 times negative 4 is positive 4. You're going to be adding or collecting negative 2x and negative 2x so that you end up with x squared minus 4x plus 4. Then we have to add that to the plus 4 squared, so that's plus 16. And that all equals x squared. Now we're going to subtract x squared from both sides, and we're going to collect these two terms together. So when we do that, we get negative 4x plus 20 equals 0. We're going to subtract 20 from both sides. And lastly, we will divide both sides by negative 4, getting x equals 5. And so we've solved for that problem. And here's example number 3. So draw this triangle, write them down, pause the video, and then check to see if you can do the problem, if you got the answer right. So the legs are x and 14. We square them and add that together, and that equals 50 squared. We're going to subtract the 14 squared from both sides. So now we have x squared equals 50 squared minus 14 squared. Taking the square root, we'll solve for x. And now we just need to simplify the radicand. So we've got 50 squared minus 14 squared. is 2,500 minus 196, which gives us a square root of 2,304. Now, that's a big number to try to simplify, so always try first, put it in your calculator to see if it's exact. If you get a decimal answer, you're going to have to figure out the simplification by factoring out perfect squares. But lo and behold, you put that in your calculator and it is a perfect square. The square root of 2,304 is 48, so that is the answer for what is x. Now, there's another topic with Pythagorean theorem, and that has to do with these groups of three called Pythagorean triples. And a Pythagorean triple is when you've got a squared plus b squared does in fact equal c squared, meaning the three lengths are sides of a right triangle. That if those lengths, a, b, and c, are whole numbers, no fractions, no decimals, but whole numbers, then we call the triple, a, b, and c, the set of the three numbers, a Pythagorean triple. So let's just test a few out to see if it works. So example, I'm going to give you a set of three numbers and ask if it's a Pythagorean triple, 3, 4, and 5. Well, first of all, we have to make sure that it actually fulfills the requirement. A squared plus b squared does equal c squared. Are they sides of a right triangle? And so we plug them in and we find that 3 squared plus 4 squared is 25 and 5 squared is 25. So yes, indeed, a squared plus b squared does equal c squared. In this case, 3 squared plus 4 squared does equal 5 squared. And the numbers 3, 4, and 5 are integers, or they're whole numbers, no negatives here. And so therefore, yes, 3, 4, 5 is a Pythagorean triple. Let's try another one. The numbers 2, 3, and 4. So we plug them into the same thing, the 2 squared plus 3 squared, and we want to double check, does that equal 4 squared? So we've got 4 plus 9 is 13, but 4 squared is 16, so no, 2 squared plus 3 squared does not equal 4 squared. They're not a Pythagorean triple, and in fact, it's not even a right triangle.